So we got 35, 40 minutes. All right, let's do, we're not going to finish. That one's super long. But I just want to start so that we're able to finish it after the exam on Monday. All right, we can't get too behind because there's harder stuff coming. I don't want to have to rush it on you later. So let's keep going. So estimating a population proportion. All right, let's key concept. Point is, yeah, I don't know if I like all this. It doesn't. I don't think it makes any sense until we get to an example. So let's just get to an example. Here we are. Here's a Facebook example. Okay, a Gallup poll. We talked about George Gallup and how he came up with the whole thing, right? A Gallup poll was taken in which 1,487 adults were surveyed. And 43% of them said that they have a Facebook page. Is Facebook still popular today? Sorry, I'm noticing out of it. Social media. Is it all MySpace now? All right. Whatever. Based on that result, find the best point estimate of the proportion of all adults who have a Facebook page. In other words, what if you really wanted to figure out what percentage of adults have a Facebook page? How would you do it? Well, you would, ask a bunch of people, right? Random survey. Okay. Well, what if in your survey, you found out 43% of the people you asked have a Facebook page? But you realize that's just a survey. Or if you're trying to figure out who's going to vote for whom in the next election, and you ask 1,487 people, and you say 43% are going to vote for candidate A. How do you know how reliable that number is? You see, what we're getting into, chapter 7 is the beginning of the most important statistical stuff we're doing. The really useful stuff, like what is it really all about? Especially the stuff in chapter 7. If you get 43% of the people you asked that say they're going to vote for candidate A, how do you know how reliable that is? Maybe you just got a freakish group, right, that just happened to really be into candidate A or not into candidate A. How do you know how, could there be a lot of luck in there? Could there not? How likely is that? How reliable is that number? That's the kind of thing people want to know. That's why they use statistics, right? If you're basing your election on it, or if you're basing your medical treatment on a new cancer treatment that says we tried it on 1,487 patients and 43% of them improved, and how do you know how reliable that is? What does it depend upon? Sometimes these things really matter, and we want to know how confident we can be. We're going to form what's called confidence intervals here. We're going to nail down some percentages of sureness. That's really why statistics is useful. And what you'll see when you read articles on statistical studies often is what we're going to do right here, confidence intervals. So here we go. So 43% is our starting point. We're going to form a confidence interval, which is an estimate. And yeah, we don't need to worry about all that. We're going to form, a lot of times what we do is a 95% confidence interval. Why 95%? Because remember, we say anything beyond 5% luck is significant. So in other words, if we form a 95%, if we're 95% confident that the real deal is in this zone, then that's believable numbers, right? There's only a 5% chance we've made some error. That's what most of the world would consider beyond reasonable doubt, like they do in a court of law, right? When you decide guilty or innocent, beyond a reasonable doubt. Beyond a reasonable doubt. Okay, so that's what we want to be able to do with statistics. Coming on in here, so interpreting confidence interval. So what does it mean? Say you come up with the interval 0.405 to 0.455. Remember, we're trying to estimate what's the true percentage of adults that have a Facebook page. What is it really? There's some true percentage of all the adults in the world, or maybe in the United States or whatever, there's some true percentage, and we're doing our best to get at the truth. Kind of like what they do, especially in polls, right, for an election. They do all they can to figure out who's going to win, because the real thing's coming, and they'd like to know ahead of time. Especially a lot of businesses, depending on their investments and stuff. So how do you get to the truth? There is a truth. How do you get to it ahead of time, or how do you be confident? Well, suppose you have a confidence interval that says it's between 0.405 and 0.455. That's 40% and 45% basically. Right, we said 43. Didn't we come out with 43 in the middle? 43, we said we thought that it was 0.43, but we're not sure it's exactly 43. If you go out and ask a thousand people who they're going to vote for, and if 43% say they're going to vote for candidate A, you don't think, hey, it must be exactly 43%. In all the United States, they're going to vote for candidate A. I'm sure I've got the exact, no, you're thinking, I might be close. It might be around 43%. And so what we'd like to say is, we are 95% confident that the interval from here to here, 0.405 to 0.45, actually does contain the true value. Because there is a true value out there, which, the election's the perfect way to go, because you find the truth, right? Election day comes, and a certain percentage show that they actually are in favor of candidate A, right? So they poll, and then the truth comes. And we see how accurate their polling was. So that's the kind of thing we're talking about. It's wrong to say this means 95% of sample proportions. No, not 95% of sample proportions. There's a 95% chance the real value is in there. That's what we're interested in. Make sense? You'd be interested if you had cancer and there was a new treatment and you want to be 95% confident that the real success rate is, whatever it is. So that's the kind of thing we're doing. So there's different confidence intervals. We're saying 95% of the confidence intervals will hit the real value. It probably doesn't make a lot of sense. So how do we figure that out? Let's get to an actual example. So here we go with the 43% example. How are we going to work it out? There's something called a margin of error. We'll talk about that. The proportion. Let's get to the details. So basically, they calculated the margin of error. They got this range. How do we go about getting those numbers? Let's see what they show. And based on the confidence, it appears that fewer than, so they're going to try to conclude that. So how do we form a confidence interval? So go down, choose one prop Z. Y'all getting that? Yeah. And it'll ask you for the X. So what is the X? It is how many, and the N, it's going to ask you for an X, an N, and then a C level. So the X is how many did the whatever you're doing. In this case, had a Facebook page. The N is always in all statistics formula, N equals total number. Total number surveyed, right? That's always in. So how many did they ask again? I'm going to go back. Here it is. 1487 and 43%. Well, how many? They didn't tell me how many. I guess I'm going to figure that out myself. 1487, 43%. So this is 1487, and they're telling me 43%. So I'm going to take 0.43 times, this isn't normal. You don't normally have to do this yourself. We better do that ahead of time. Somebody got there? What is 0.43 times 1487? Somebody have that number?
It's 639.
639 exactly?
No, 0.41.
0.41. So, wait a minute. I'm sorry, I'm getting confused. 1487 goes down here, huh? 1487 goes there, and 639 goes there. Thank you. What that means is, normally they just give us this number. 639 people out of 1487 said they had a Facebook page. That's what so the X is how many did the whatever, N is the total number surveyed. So 639 people out of 1487 said they had a Facebook page. So we put those numbers in there. And the confidence level, we want a 0.95. We want a 95% confidence level. 0.95.
It has to be that all the time?
No, they'll change it on different ones. This one we're doing a 95% confidence interval. And then you just hit enter on the calculator. And I got 0.40, I got 0.4046, 40456, and 455. Yeah, I got rounded. I got those two numbers. Did you get those numbers in parentheses?
Is that 6.39?
No, just 639. Oh. It's 639 people. Yeah, it looks like a decimal there, doesn't it?
That's the sea level?
Yeah, so what that means is, so everybody getting those numbers first off in the calculator? Okay, so so do you understand what that number means? That means we're 95% confident, we're pretty sure, 95% sure, that the true percentage of adults who have a Facebook page is somewhere between 40.4% and 45%. We're pretty sure the real percentage is somewhere in that zone. That's what we're saying. So, their next question is, based on that, what if you wanted to write an article? So this is kind of thing when they write an article and they want to make a statistical statement about something with confidence. Could they say confidently that fewer than 50% of adults have a Facebook page? Yeah, because we know there's a 95% chance that the real percentage is somewhere between 40 and 45. So yeah, we're real confident it's below 50. Now, could we be mistaken? Of course. You could always have grabbed a really weird group, but it's not very likely. We talked to 1,487 people. Could they have all just been weird? Could be, but that's not very likely. That's what we're finding out. We're 95% sure that the real percentage is between 40 and 45. That makes sense? So this is where statistics is really used. This is what people mean when they write articles and make statements about confidence and sureness based on studies. This is exactly what we're doing. Basically, the bigger that number is, if we had only talked to like 10 people, we would have found a confidence interval that is very different because we couldn't have been very confident then. All right. So, and there's the summary of the results. Yeah, that was the United States Gallup poll, 43%, 95%. In theory, 95% say that. So, all right, high-dose nicotine patch therapy, blah, blah. So it's another example. Let's skip that and get right. I think it's best just to do some homework. That makes more sense. So let's look at an actual homework question. We've got 20 minutes. Let's look at a few homework questions. Then we'll go back to the other stuff next time. Newspaper provided a snapshot illustrating poll results for 1,910 professionals who interviewed job applicants. These are professional interviewers. The illustration showed that 26% of them said the biggest interview turnoff is that the applicant did not make an effort to learn about the job or the company. I remember my junior college instructor telling me that, telling us all that, back in the day, that whenever you're going to interview for a job, read up on the company beforehand. I guess that makes sense. So if you're going to go there, you'll go on, whatever, find some information about the company and what they do and who they are. That's important to show real interest. Margin of error was given as plus or minus 3 percentage points. What important feature of the poll was omitted? So this is just something's missing here. If you read an article with that kind of statement, that's not very well done. That's not very academically strong. They're missing something important there. What's that? Yeah, they never say the confidence level. So in other words, do you see what are they even saying? They're saying 26% of the interviewers said that the biggest mistake was the person didn't read up in the company. But they know that it's not exactly 26%. See, they say plus or minus 3 percentage. So they're saying 26, add 3 or subtract 3. So it could really go from 23 to 29%. That's what they're saying. They're saying between 23 and 29%. Right? 26, add or subtract 3%. Subtract 3, add 3. They're saying, because, they're saying of all, so the 1910 professionals, 26% of them said that. But, which means we are thinking that the real percentage of interviewers who think that is between 23 and 29%. But how confident are we about that? Are we 95% sure the real number's in that zone? Are we 90% sure? 80% sure? How sure are we? They never gave the confidence level. Good? Makes sense? Let's go to number 2. These are just touchy-feely questions, no calculation. Number 2. Magazine provided results. 1,000 adults who were asked to identify their favorite pie. Among 1,000 responses, 11% chose chocolate. Error was plus or minus 4 percentage points. Right? Because there's always a chance of luck. That's what that error is. You never know. You could just get more chocolate lovers than average or less chocolate lovers than average. There's always some luck that can get in there. But how much luck? That's what we're doing. That's what we're calculating here. Describe what is meant by the statement that the margin of error was given as plus or minus 4 percentage points. What does that phrase mean? The margin of error plus or minus 4 percentage points. Does it mean the statement indicates that the study is 100% minus 4, 96% confident? Is that right?
No.
No, they're not saying they're 100 minus 4. First off, what are they saying? What does that mean? Error plus or minus 4 percentage.
It could be 11% plus.
Yeah, it's 11% plus 4% or 11% minus 4%. That's what they're saying. From 7 to 15, in other words, right? This is 7, 11 minus 4. This is 15, 11 plus 4. They're saying we're confident it's between 7 and 15. That's 11 plus or minus 4. So the statement indicates that the true percentage that preferred chocolate pie is 11 plus or minus 4. Yeah, right. What's wrong with the other ones? Only 4% confident? No. That the interval is likely to contain? No, it's B. There we go. All right. On we go. Number 3. Magazine provided, same kind of thing. 500 respondents, 13% chose chocolate pie. Margin error plus minus 3%. Give specific sample data. Given specific sample data, which confidence level is wider? So think with me for a second. This might be counterintuitive. What do you think is going to be wider? A 99% confidence interval or an 80% confidence interval?
80%.
So think for a second about this. So if I said, how can I make this real for you? If I said, okay, I went out and I asked 1,000 people, or I guess they did 500 people, 500 adults, some kind of question, their favorite pie, and 13% said chocolate. If I said, that was just 13% of the 500 I spoke to. I don't know if that's really true of the whole population in the United States, that really 13% of all people, chocolate's their favorite pie. Maybe the real answer is between 12 and 14%. That's a more narrow interval. What if I said, no, I think it goes all the way down to 10 and up to 16%. That's a wider interval. Would you be more, if you had to bet your life on it, and you're saying the real percentage, the election day's coming, everybody's going to vote what their favorite pie is. November 11th, we're going to vote for pie instead of whatever. What's our favorite pie? Tomorrow's Pie Day. That's right, it just occurred to me. I don't want to geek out for you too much, but they have a, what they call, they have a parade in San Francisco, I think, for this. Why is it Pie Day? What am I talking about? Yeah, a lot of you guys know. March 14th, 3.14, pi. Anyway, it just occurred to me. Tomorrow is Pie Day. I'm a math teacher. I feel like I got to say that. All right, tomorrow's Pie Day. Anyway, which one, if you said there's some true percentage, if they were going to have an election, I asked 500 people in a poll, I want to find out what's the real percentage of people that chocolate's their favorite, and then they come up on election day and everybody votes, and you had to bet your life on it. Would you rather, I say, well, I got 13%, I talked to 500 people, 13%. I think the real thing's 13%. Would you be more sure that the real true percentage on election day will be between 12 and 14 or between 10 and 16? Which one would you be more sure? The real percentage.
10, 16.
Yeah, the bigger interval. Right? We want more room for error if you want to be more confident. Right? Whereas this is more tight. That's more, if you're just a little off and it's 11 instead of 13, you lose. If you said, I'm sure it's between 12 and 14, well, it was 11, sorry. Or it was 15. But if it's 11 or 15, and I just said I was sure it's between 10 and 16, I'm still good? Mm-hmm. Wider interval gives you more confidence, doesn't it? Gives you, wait, I'm probably saying that totally backwards. Wait, let me try that again. 99%. Yeah, no, that is right. That is right, yeah. So we would be 99% confident that it's in a wider interval. We would be 80% confident of a more, we'd be less sure of a more narrow interval. Does that make sense? We would say we're 80% confident. We're less confident in a more narrow interval. It's harder to be sure when you really pin it down, right?
Yeah.
Does that make sense? So which one is that? The 80% is more narrow, isn't it? So the 80% must be wider. No. Wider. No. The 99% must be wider in order to be more confident that it captures the true value. Yeah, that sounds right to me. The 99% must be wider because it contains 90%. No, it doesn't. Yeah, B. No. All right, that's tricky. Let's move on. Enough with that tricky stuff. Number 4. All right, let's express the... So they're going to have me do one backwards here. These are all kind of weird questions, aren't they? All right, so just a few of these weird questions. Suppose they give you a confidence interval, which goes from 0.111 to 0.777, right? And they're saying, hey, can you rewrite it another way for us? Can you rewrite, what is this stuff? Well, this means, can you put the middle here, plus or minus the error? That's what P hat, that's called P hat. That little arrow above it is called a hat. Sounds like I'm making stuff up, doesn't it? But that's the official name. That's called P hat. So P hat, which means the sample middle, and plus or minus the error. So how do you find the middle? So all they're giving me is the left edge, right edge. So imagine a number line. Let me help you. Let me put this on a number line. They're basically giving me a number line. And they're saying it goes from 0.111 to 0.777. There's some middle, which is called P hat. That's the average. How do you find the middle of two numbers? Add them and divide by 2. It's the average, huh? So first thing, to find the middle, you got to add. I know these are weird questions. We're going to get to the normal ones probably when we run out of time. And add them up. Is that 0.888 over 2? So that's 0.444, yeah. Who needs a calculator? 0.444. So that must be the middle. Okay. How far now? And the error is how far this way and the other way. It's how far the jump from the middle to the edges. Yeah, so how much is it from 0.444 up to 0.777? Yeah, it must be 0.333. And same thing the other direction. This must be minus 0.333. This must be add 0.333. Right? Did you see what we did there? Is that confusing? I just added them and divided by 2 to get the middle. And then from the middle to the edge, just subtract those. It's 0.333. It's the same amount. So that means what we really think the percentage of adults who like chocolate pie best or whatever, 0.444, but we know we might be in error, give or take 0.333. Right? That's the error. We know we could be in error because luck could always get in there. So what do you want me to write here? 0.444, the middle, and then the error, 0.333. That's what they want. They're saying it's the middle 0.44, give or take, add or subtract 0.333. That we're done. They just wanted me to fill in those two blanks.
How did you get the 0.333?
I subtracted the edge from the middle. Yeah, so the error is how big the jump is from the middle to the end or from the middle to back to the beginning. That's the error. So we found the middle by adding and dividing by 2. And then the way I found the error jump is I found the gap. I subtracted. The error is the amount of jump from the middle to the end. Or you could take middle minus beginning, either one. It's the jump amount from the middle to either end. That's the error. So we think the true percentage of people that like chocolate pie best is 0.444, give or take, possible error, 0.333 in either direction. So we're pretty sure that the real percentage of people like chocolate pie best, 0.111 to 0.777. That's what that's saying. All right. We'll move on. Number 5. One more weird question. Express the confidence interval. Oh, that's easy. That's just 0.050 and 0.104. There's nothing to that. Just put the left number on the left and the right number on the right. They're just making sure you know that that's what those parentheses mean. They mean from here to there. 0.05 to 0.10. 0.104. 0.050 to 0.104. All right, let's go to number 6. For good on all those kind of goofy questions. Here's a real question. All right, let's do at least one real question before we're done. This is probably all we have time for. Let's do this one real question. You guys have your calculators? So those are all kind of weird questions. Here's the regular, normal kind of question you'll get a bunch of in this section. Here we go. I just wanted to get one of these done. Clinical trial tests a method designed to increase probability of conceiving a girl. So I've been studying this a while. In the study, 520 babies were born. 260 of them were girls. Use the sample data, construct a 99% confidence interval estimate on the percentage of girls born. Based on the result, does the method appear to be effective? So in other words, suppose you're a doctor, you're a medical researcher, and you come up with this new thing that you think is going to help couples have more girls. And you test it out. And a bunch of babies are born. 520 babies are born. 260 of them are girls. Now, there's always the chance of luck, right? It could always be that those couples were going to have more girls anyway. You understand the issue? The issue is, I feel like that could be the subtitle for statistics. Statistics, or what about luck? Right? What about the chance of luck? Can we rule that out? That's basically what we're doing all the time. Is we're saying, how reliable is this information? What about luck? Could it be that this medical treatment's doing nothing, and these couples were just going to have more girls anyway, naturally, and the medical stuff's doing nothing? Could that be? Well, yeah, that always could be, but is that reasonable? That's what we want to examine, right? It reminds me of my family was just watching. I came home the other night. They were watching the old O.J. Simpson. So what's the probability of that? Let's be mathematical. Anyway, okay. So right here, 9. So that's what we're doing. We're always saying, what about luck? And a jury decides exactly that, don't they? In a criminal case, anyway. The jury's job. Because could it always be that some crazy alien came down and took over somebody's body and did the murder and flew out of there? Well, yeah, maybe. But what's the chance? Is that reasonable? Right? I mean, there's always the chance of some crazy thing. But the job is beyond a reasonable doubt. Same thing we're doing in stats. It's always what's reasonable, right? What's reasonable? Luck is always a possibility. What's reasonable? Okay, so 99% confidence interval. 520 babies born, 260 girls. All right, so go to our stat thing. Stat, and what is it? Stat, I've already forgotten. Yeah, stat, test. That's it, test. Go over to tests. Tests. Hit enter. And go down and choose the, what is it? 1 proportion Z? A. Yeah, I don't know if it's A on everybody's calculator, but it is on mine. That's true. So go down to, what is it called? 1 proportion Z interval, and put in the information. X, so what's X in this case?
260.
Yeah, the 260 girls that were born. What's in?
520.
520 couples that had babies. So 260, 520. What? Now what? They wanted 99. They want to be really sure.
0.99.
So yeah, put in 0.90 into the confidence interval. 0.99. Calculate. I'm getting, let's see, I got 0.44. How many places they want? 3 places. 445? No, 443. 444. I'm having a rounding problem. 444, 556. So 444, 556. Okay. So what does that mean real life? So that's almost the most important thing, right? You're probably never going to actually, you might, but more than likely instead you'll read somebody's research and have to know what it means. What does this mean?
0.5%.
We are 99% confident that the true percentage of girls that are going to be born to couples with this medical treatment, right? Because they tested it out on 520 couples, right? 520 babies were born using this medical stuff, and we want to know this medical treatment, what is it truly going to do? What is the true effect? What percentage are going to be born girls truly? Well, we're 99% confident that it'll truly produce a percentage of girls in this zone. Like, if you keep using this medication, for 100 years, what will it do truly? It'll produce percentage of girls somewhere between 44% and 55%. Is that good? No. It's not even above, we're not even sure it's above 50. Right? So this is not good results for the medical treatment. So does it appear to be effective? No, it's not even coming up, it's not even above 50. All right.